Looks like we're getting folks starting to pour in, so we're going to go ahead and
Good.
get started. I want to thank everybody who is joining us and remind everyone to please use Whova to post questions so those live on past the session. And to launch our session, I'd like to please welcome Dr. Bruce Betts.
Hello, all. I'm Bruce Betts, the Chief Scientist at the Planetary Society, and today we're going to talk what we've called backyard astronomy, but it's astronomy for where you can do from anywhere. We've got a great panel. We'll be talking about easy things to see in the night sky with just your eyes, getting acquainted to the sky. We'll hear about picking a beginner telescope, and hear about astrophotography and how to share the night sky with the world. And we've got some of the best experts, certainly that I know, and in the universe here with us to share. I'm going to lead things off and present a little bit on the easy things to see in the night sky to get yourself acquainted. And I'm going to work on sharing my screen. Meanwhile, we will have barking in the background for my dogs periodically, just because they want to say hi. All right. Gio, nod your head if you can see my presentation. Thank you. All right. So, the night sky. There are many things you can see with just your eyes, and it seems obvious, but people often think of, well, I need a telescope, and I need a big telescope, and those are fun, but you can get a lot out of the night sky, and in fact, get some ways a better introduction just using your eyes, and there are a lot of great things you can see. Then you can move on to binoculars or telescopes, and we'll hear more about that later. I'm going to go through some content tips and a few types of objects you can see. Some of this will be things many of you already know, but some of it won't be, so it'll be exciting. All right, here's an important point. We have placed on Whova in the session, down at the bottom is a link to a resources document, PDF. And so it includes all the things you see on your screen here with links on various objects of how to find them, how to study them, links to articles from all over, and social media and other links from our speakers. I noticed that the first link on the page that said with the word here did not work for me, but if you click on the ones below in the box, you can download that, and that way you have clickable links to find out more. Okay, I'm shamelessly mentioning, I have a book called Astronomy for Kids. Easy things to look for in the night sky, basically. But I like to point out, it's not just for kids. The publisher thought it was just for kids, but I think it's for anyone who's kind of starting out and wants easy ways to go from one constellation to another. If you want, and all the stuff I'm going to discuss is out of that book, basically. Tips for seeing, we will also start with, thank you, Captain Obvious, avoid bad skies. Clouds, that one's really obvious. If you can get out of bright city lights, you're going to do much better. The moon, try to avoid when the moon is up, unless, of course, you're looking at the moon, but otherwise it washes things out. Get that flashlight out of my eyes and that phone. Here's a point that a lot of people, and particularly in modern society, don't fully appreciate, that your eyes take many minutes to adjust to the night sky and to see the objects the best that you can. And as soon as you look at a bright phone or a flashlight, and if just a reminder, if people could stay on mute that are on the call and have your video off, it'll help the stream for everyone else. Thank you. So you need to be wary of using modern technology and give your eyes time to adjust, and you'll see much more in the night sky. This one I throw in just as a random tidbit, which is I like to remind people to look for color. Now, your night adjusted eyes don't see color really well, but you will see color differences.
It's just weird. It's just, it worked just fine. Okay, thank you. I see the screen. I just can't hear anything they're saying. Okay.
Well, and then apparently
Thank
can't
you.
hear to please mute, but thank you. Okay, moving right along. Reddish stars, blue stars, red Mars, these things are all things you can detect. Hey, why did the sky move? Again, to state what's probably obvious, but we'll mention it anyway. There are nightly changes from the sky moving. which is really the Earth rotating. And there are seasonal changes. So as the Earth orbits the sun and the night side is facing different parts of the so-called celestial sphere, we're seeing different things. What's really the point of this statement is to find things in the sky, you need a season, you need a date. Ideally, depending on what you're looking for, you at least need a general range of dates. And you need a time of night because things will be in different parts of the sky or even rise and set during the evening. And if you look in those resources from that handout, that's where you'll find the answers to the questions. Well, how do I find out what's up when? So you can specify direction to things, and then to find something, you can point out, hey, look in the southwest, look about halfway up in the sky. But you can also find things by jumping from one thing to another. For example, using the Big Dipper to find the North Star, and you can use that same line to find the constellation Cassiopeia. All right, things to look for in the night sky. Well, oddly enough, there are stars and constellations and asterisms. What does that all mean? We'll talk about that in just a moment. Advantages of looking at stars and the like is they don't move relative to each other, at least on human kind of time scales. And they're pretty much in the same part of the sky at the same time every night with gradual changes throughout the season. This is as opposed to some of the other things we'll talk about. Obviously, there are bright stars and dim stars. If you have dark skies, you're going to see that couple thousand stars conceptually. If you're in the middle of New York City, you're going to see a few stars. And then there's also just kind of versus planets. Planets, we have pictures on Mars, hence this Planet Fest. And so there's a sense of reality to it, whereas the stars are more removed and a little more philosophical, although there's plenty of science. All right, wordplay, star patterns. Constellations, we refer to them all the time. About 100 years ago, the International Astronomical Union agreed on 88 constellations in the northern and southern hemisphere skies, the whole sky. There are 88, no more, no less. And they're not only just collections of star points, they are also dividing up the sky. Each constellation represents a part of the sky, like a state in the US or like a country boundary. For example, an example of a constellation is Ursa Major. Asterisms are kind of everything else. They're anything that you connect the dots and see a pattern. For example, Big Dipper. And by the way, historically, there were plenty of other constellations. Obviously, there are different cultures, draw different asterisms, different lines, have different stories, but there are 88 official ones from the IAU. So this is Ursa Major, the Greater Bear. It is a constellation. This is the Big Dipper, or the Plow, or all sorts of other names in various countries and cultures across the world. It is an asterism. That is the Big Dipper inside Ursa Major. So you can connect dots kind of however you want. And some constellations, I think, the official connecting the dots look like what they're supposed to be, and others require a lot of imagination. So for example, here is Canis Major, the greater dog, one on the bottom. I can buy that. Looks kind of like a dog. Up above, Canis Minor, the little dog. I don't know. I mean, I guess if you have an imagination, then it looks like a dog. But so some of don't assume the constellations will look exactly like what they represent, but you can still learn the patterns and you can make up your own images and pictures. Bye-bye. All right, just a few things, the highlights. So if you're in the Northern Hemisphere, sorry to those who aren't. And if you're in mid-latitudes and up, sorry to those who aren't. There is the northern part of the sky is going to be visible year-round, whereas other things are going to be very seasonal. And that's because of where we're pointing in the celestial sphere. An obvious example is, once again, the Big Dipper. You'll find it in the north. It could be a little northwest, could be northeast, but you'll find it up there somewhere, looking sort of obvious if you have a cloudless night. You can use that. I'm sorry, this is the Eagle Scout in me. You probably know this, but if you don't, this is how you find the North Star. Pointer stars from the Big Dipper will lead you to Polaris, which is always north. Again, only going to be able to see that from the northern parts of the Earth. If you keep following that line, you will end up at CAF, which is part of this. Oh, that's exciting. Whoever's drawing on my screen, if you could not, that would be great. Which is part of Cassiopeia, which looks like a W or an M, depending on season and which way you're looking. Another kind of obvious constellation in the north. All right, planets, another option. Several are bright. That's the good news. You can tie them to that reality of spacecraft images. Disadvantages, they move. Now, they don't move radically from one night to the next, but they move from day to day, night to night, depending on the planet. You can actually watch this movement, which is kind of a good news, bad news thing. But you have to know more where to look. Planet, by the way, comes from the Greek word for wanderer, because they were what moved relative to the fixed stars. 5 of them easily visible with your eyes if they're up and if you're looking in the right direction. Venus, by far the brightest. Venus and Jupiter brighter than the brightest star in the night sky. Saturn, bright yellowish. Mars, we'll talk about Mars. Mercury, always pretty low to the horizon, near the sun, tricky to see, but pretty bright. What do they look like? Well, they look like a dot. If you can see over on the left side, that's a picture I took, a magnificent picture of Jupiter. You can see all the cloud bound. No, it looks like a dot to your eyes pretty much, and relative to the moon, obviously. Here are smaller dots, well, bigger dot with Venus because it's bright. Again, we're just, it's appearing that way on the film. In reality, at least with your eyes resolution, these are going to appear as dots. And this is Venus and Mars and a crescent moon. Saturn's rings, I throw in a page showing that to remind you, hey, if you haven't seen Saturn's moons through a telescope, Saturn's moons, that you can do that too. But I meant Saturn's rings. It's really kind of profound that you're seeing rings 1.5 billion kilometers away, billion miles. All right, how about tonight? Where's some practical information? Here we go. If you look in the early evening, and again, everything I'm going to talk about is visible for most of the Earth. The orientations will change some depending on your latitude. If you're in the mid-northern latitudes, it's going to look pretty much like this, which is based on Pasadena in California. Early evening, there is just a hint of a crescent moon. These were made using the Stellarium free program. You'll find it in your resources handout. And then we've got Orion in the southwest-ish in the early to mid-evening. Bright stars Rigel and Betelgeuse, and brightest star in the sky, Sirius. If you follow Orion's belt to the left, you'll find Sirius. If you follow it to the right, you'll be just under Aldebaran, the brightest star in Taurus. And right now, Mars is over to the right. So check out Mars in the evening south, and you can compare it to Aldebaran. They actually happen to be very similar in brightness right now. They're similar in color. They're kind of twinsies. Mars varies considerably in brightness because of its orbit relative to the Earth. It ends up much farther and much closer at various times. If you pan out, this is a very big view of the sky. You got Orion down in the middle center. You have the so-called winter hexagon asterism going with bright stars from lower left, Sirius, Procyon, Pollux, which is next to Castor in Gemini, Capella and Auriga and Aldebaran. And we add Mars, making a special guest appearance, and Betelgeuse kind of in the middle of the hexagon. All right, sorry for the speed, but again, you can find more in the resources. Moon, obvious, good to look at. And we have a great, in the resources, you can find the planetary sign night sky page. There's a great resource showing a description of what the dark things are called, the mare, the basaltic regions. You can easily see with your eyes the dark basaltic regions, which are somewhat younger, but still really old, and the older heavily cratered highlands. Meteor showers, streaks of light. When we run into clouded debris, dust, and sand from comets that they drooled into the solar system in the past, then these pieces of dust and sand hit the atmosphere going tens of thousands of kilometers per hour, and they burn up, they make a streak of light. They are predictable. Meteors happen all the time. but you can find meteor showers and predictions in the resource sheet, once again, where you can find those. Perseids in August, Geminids in December tend to be the two best ones on average. Just stare at the sky. There's a picture of a Geminid passing by the North Star. This is not what you will see when you look for the space station at night. It will be what you see if you're on a spacecraft near the space station. But you can see space station flyovers pretty easily. Again, use the resources document to find out when and where to look. You have to get predictions for your region, and then you can see it looking like a really bright star crossing the sky over a few minutes. And finally, here's your reminder, download the resources handout. Look for things. I'm going to make an attempt to stop sharing my screen. Success. And if I can manage the windows, I will take a quick question and then get to our other speakers. I know there was a question. I'll look in more detail at questions in a little bit, but there was a question about during the pandemic, we tend to be stuck. If you live in a big city, you're probably always in the big city. What can you look at? Well, that's where looking at the bright stars and the bright planets are going to be your best bet. You're going to have trouble seeing deep sky objects, even the dimmer stars, but you can still watch the bright star patterns like Orion, like the Winter Hexagon, are actually excellent targets, as well as Mars right now, and coming up, there'll be other planets in the coming months. So with that, we'll come back to more questions at the end. You can enter them in Whova. With that, I turn things over to Cheyenne Polius, who has written a magnificent article on the Planetary Society website about how to look for a beginner telescope. She is in the UK now, right at this moment, but is from St. Lucia. She founded an astronomy association in St. Lucia. She is a master's in astrophysics and is going to tell us about telescopes and the like. By the way, I'm giving pretty short intros to all these very interesting people. You can find longer bios from the Whova link in our session. Off to you, Cheyenne.
Thanks, Bruce. I'm just going to share my screen now, start presenting. So official hi everyone, like Bruce said, I'm Cheyenne. I'm currently the president and co-founder of the International Astronomy Association, and generally just someone who's very obsessed with astronomy, which is probably why I ended up doing an entire master's in it. But today I'm here to talk to you about how to pick your perfect beginner telescope. If you are thinking of getting a telescope, or if you have been looking around, this is just a very basic guide going down to the fundamentals of what makes like different telescope designs and what makes a good telescope or a better telescope, depending on what you're looking for and what you want to see in the night sky. So like Bruce mentioned, there is an article on the Planetary Society website and also in the speaker articles on Whova. So everything I'm saying here today is in that article. So if you want to go back to anything that maybe you don't remember, it's all in there. So starting off, the main things we're going to talk about today is going down to, like I said, the fundamentals of telescope design. So looking at things like the aperture of a telescope, the magnification, the different types of telescope mounts, the different designs, and then the cost of a telescope. So going more into detail about what all of these are and what that means for you picking your beginner telescope. So the first thing is aperture, and that's just the size of the telescope's mirror, primary mirror or lens. So the bigger the aperture, the bigger the telescope. The reason that aperture is important is because a bigger aperture means that your telescope can collect a lot more light, so you can see fainter objects or you can see more detail on bright objects like the moon. So ideally, in a perfect world, you'd want the biggest telescope possible because you'd be able to see pretty much everything in your field of view in the sky because you'd be able to collect so much light. But so thinking about amateur telescopes, 4 to 5 inch telescopes, 4 to 5 inch aperture is ideally where you want to start with your very first telescope, because you can see some of our favorite night sky objects. You can see the moon really well. You can see the craters on the moon. If you get solar filters for your telescope, you'll be able to see the sun, Jupiter and its moons, and Saturn, and they all look so amazing through a telescope. If you are interested in seeing fainter objects, fainter deep sky objects like galaxies, star clusters, nebulae like the Orion Nebula, you will need a telescope that's bigger than 5 inches. But before you go out and buy the biggest telescope your budget can afford, you do need to consider how practical that might be. So the bigger the telescope, the heavier it is, the less portable it is. You need to think about, if you do get a big telescope for, let's say, like maybe a 12-inch telescope, it's probably almost like my height. I'm like 5'3". But if you do get a telescope that big, will you really want to drag it out into the backyard every time you want to use it? If you do want small children to be able to use it by themselves, are they going to be able to carry it out? If you want to drive somewhere out to your favorite dark area or any stargazing events, I mean, post-pandemic, but you will have your telescope for a while. So it's just something to consider, that yes, a bigger telescope, you'll be able to see more, but just thinking about practically getting into the hobby, how realistic is it for you to get a telescope that would be very big? So the telescope on there right now is one of the Planetary Society member recommendations, and it's a Celestron made one sky reflector. Now this one I chose to put onto the slide because it's what's called a tabletop telescope. So it's very portable, very easy if children want to use it. And as you can see, it's kind of like extendable. So right now it's fully extended, and that top half of it can collapse back down onto the tube. So that makes it even more compact. So you get the length of the good length of a telescope, but in terms of transporting it, you can collapse it back down, making it a lot more portable. So just one of the examples of a more portable telescope. But if that's not a big issue for you, then you can go for the 6-inch Orion SkyQuest, which is not the collapsible design as this one, but is a great beginner telescope. And like I said, all of these recommendations that are in the slides are going to be all in the article as well. So you can go in there and they're all linked. So you can find them on the websites as well. So the next thing is magnification. And this is something you're going to see a lot, or maybe you have seen a lot while you're looking into getting your first telescope. It's kind of plastered all over the websites. And magnification is important, but it's not everything. So just going into what magnification is, it's the focal length of your telescope. So how far the light has to travel from the time that it enters the telescope to the time that it's focused into the eyepiece, and that's divided by the focal length of the eyepiece. So magnification is like the longer your telescope, so the longer the focal length of your telescope, for a given size of an eyepiece, the bigger the magnification. That's just a little bit of detail into magnification, but it's just all that just to say that you can have a different magnification on your telescope if you change the eyepiece and you have a different focal length eyepiece. So getting a telescope doesn't necessarily mean that you commit to one magnification, but the important thing to think about when you're considering magnification is that the purpose of it is to zoom in on the image. So for example, Jupiter and Saturn, they're quite far away. So looking into a telescope that doesn't have a great magnification, they can look very tiny, and you want to be able to see the image as big as possible. But the aperture of your telescope still limits the amount of detail you're able to see. So if you have a small 4 to 5 inch telescope, having a large magnification and trying to really zoom in on that image isn't going to do much for you if your telescope isn't collecting enough light to see that detail. So the general rule of thumb is, if you have a 4 to 5 inch telescope, magnification more than 200 times is not going to do much for you, because you will only be zooming in a blurry image because your telescope can't collect enough light to get those details. This is just the picture on the right is a picture taken by an amateur astronomer in St. Lucia with an 8-inch telescope. And it's just one of my favorite pictures because it's so much detail, seeing like the craters on the moon. So it's just an example of the views you get to see depending on the size of telescope. But if you were to zoom in more and more and more, there's only so much detail you'll be able to get because the aperture still limits how much detail. And like Bruce was mentioning earlier with like seeing, the weather, the atmosphere, all of that also affects the level of detail you see. So a bigger magnification doesn't necessarily mean you'll be able to see more detail on an image. Next thing is to consider is a telescope mount. So there's two main types of mounts, and then I'll get into the third one after that. So the first one is altitude azimuth mounts, or they call them alt-az mounts, and it's very similar to a camera tripod. It moves up and down, left to right. So if you know the object you want to see is higher up and to the right, then you bring the telescope up and you bring it to the right. It's very intuitive. And that's the one I would recommend for beginners. But equatorial mounts are aligned with the rotational axis of the Earth, and these mounts are very great for tracking objects. So again, as Bruce mentioned earlier, like objects do move in the sky, and stars do move in the sky like throughout the night. So the equatorial mounts are they're built so that when you move the telescope, they're moving along with tracking that object. So if you are interested in tracking objects throughout the night, then an equatorial telescope, for example, if you want to take like long exposure astrophotography, equatorial mounts are more ideal for that. But if you're just interested in seeing what's up in the night sky, alt-az mounts are definitely more intuitive and easier to use as a beginner. Go-to mounts are computerized mounts, and the reason they're called go-to mounts is because you're telling the telescope to go to a certain object. So you put in the object you want, and the telescope automatically, the mount automatically moves the telescope to point to that object. So they're great for bright cities. If you live somewhere with a lot of light pollution and maybe you're not able to use a star chart or a night sky app to see the reference objects and then be able to say, okay, this is the reference object and here's the object I want to go to, and move your telescope manually. A go-to mount is great for that because it moves the telescope for you based off the object you want to see. But if you really do want to learn the night sky, learn where the constellations are, learn where the objects are, I wouldn't recommend a go-to mount for a beginner just because it does all of the hard work for you. So if you're very interested in learning the night sky, I would recommend one of the first two, but it is an option if you just kind of want to see what's up there. So going into the types of telescopes, again, two main types of telescopes, and then the catadioptric or Cassegrain telescope is a combination of the two. So I'm going to talk a bit about reflector telescopes and refractor telescopes, and then the compound telescope is just a combination of the two. So a reflector telescope uses mirrors to focus the light. So there's a primary mirror, a secondary mirror, and it focuses the light onto the eyepiece. And with a refractor telescope, it does the same thing, but just using lenses. So what does that mean for you picking your beginner telescopes? Generally, reflector telescopes tend to be the more popular ones because mirrors are cheaper to produce. So for the same price point, you're able to get a bigger reflector telescope. So you're able to get a telescope that collects more light and you'll be able to see more images with it. Refractor telescopes, their benefits are the fact that they're very low maintenance. All you need to do is clean the lenses and that's it. You're good to use your telescopes, compared to reflector telescopes where you have to make sure that primary mirror and that secondary mirror, sometimes it can get out of alignment, especially if you're moving the telescope around a lot and you will need to realign it. And then something else to consider is sometimes mirrors might need recoating every 10 to 20 years. In my opinion, not huge deal breakers, but it's just something to consider that reflector telescopes are slightly higher maintenance, but you are able to get a more powerful telescope for a given price when you choose a reflector telescope over a refractor. Catadioptric telescopes or compound or Cassegrain telescopes, that's the three names you might see them by. So they combine lenses and mirrors to focus the light, and because of the design of the telescope, you're actually able to get a lot more magnification and on a lot more compact tube. Because remember I said earlier, magnification depends on how much distance the light travels before it's focused. And because of the design of the compound telescope, the light actually has a long path because it's being bounced back and forth inside the telescope more than the other two types. So you're able to get a much more powerful telescope in a much more compact tube. So they make really great tabletop telescopes, and they're a lot better for portability. Okay, so now you know the basics of the different telescope designs, different telescope mounts. what does that mean for you now if you are thinking of getting a telescope or you're in the midst of your search? So it's a balance of what's your budget versus what you need in a telescope. Generally, beginner telescopes, good beginner telescopes are in the range of $200 to $400. You might be able to get ones around $100 depending on the design you choose. Some tabletop telescopes can be cheaper, but generally you're looking at $200 to $400, with $400 being the computerized mounts, which tend to be a bit more expensive. But just because you can afford a $400 telescope doesn't necessarily mean that you should buy one. So like I mentioned before, you do want to think about the practicality of using your telescope. So if you know it'll be a lot easier for you to just have a tabletop telescope, and that one tends to be cheaper, go for that one. If you're comfortable with transporting around a bigger telescope and you can afford to get one with a bigger aperture, like an 8-inch or a 12-inch, then that's perfectly fine. But just think about how often you want to use your telescope, how easy you want it to be to use a telescope. If you want other people to be able to use it as well, particularly children. And the last thing is, I know this whole presentation was about choosing your first telescope or choosing to get another telescope, maybe if you already have one. But do you really need a telescope right now? And I just mean that if you are a complete beginner to stargazing and you really are interested in starting to learn the night sky, you can do so much with a pair of binoculars. And there's a recommendation in the bottom right for a good pair of binoculars, because a star chart or a night sky app and a pair of binoculars, you can see similar. So like I was mentioning before, you can see the moon, Jupiter, Saturn. You can also see the sun if you get solar filters for your binoculars. So if you're wanting to get into stargazing and maybe you haven't even started yet, you don't know if it's something you might stick to, or you want to see just how it goes, getting a pair of binoculars could be a good place to start, because they generally tend to be cheaper than telescopes. This recommendation is a bit expensive, but it's quite a good pair of binoculars. But generally binoculars are cheaper and they're a great place to start. So it's just things to consider. And if you're a complete beginner and you're not exactly sure, your safest bet it would be to get a pair of binoculars and then eventually graduate to a telescope. So that's what I had to say about picking your beginner telescope. Again, everything I said today is in that article on the Planetary Society website, and it's also in the speaker articles on Whova. So yep, that's it from me. Happy stargazing.
Thank you. I had questions I was going to pass along, and then you kept answering them, many of them having to do with what to choose, look for in a beginning telescope, and eventually what can I see with binoculars. I don't know if you wanted to add anything to that, but I was all ready for that one. So what can you see with binoculars that you didn't just tell us a few moments ago?
I guess I go into a bit more detail. So you can see craters on the moon with binoculars. I've seen craters on the moon with binoculars. You can see Jupiter quite clearly. It's small, but it's big, and it's good enough for you to actually see the bands on Jupiter and Saturn's rings as well. So although they can be quite small in binoculars, it is possible to still see them. And you can also see like the Pleiades cluster in binoculars as well. You're on mute, Bruce.
That was just wrong. Thank you for the wonderful presentation, Cheyenne. That was great. And now we're going to move on to Justin Foley talking about astrophotography. Justin Foley is self-described as an amateur astronomer, satellite tracker, Mars robot builder, and rocket launch junkie. And I can attest that he is indeed all of the above at excellent levels of excellentness. Right now, he's on call for JPL for his other job, just testing out things having to do with Mars rovers or something. But I turn it over to you, Justin.
All right, thank you very much, Bruce. Can you hear me okay?
Yes, it sounds great.
Excellent, okay. So I'm gonna be talking about astrophotography, which is a gigantic hobby field, whatever you want to call it. So this is gonna be a very high level description of what astrophotography is and what you can do with different levels of equipment, and with different types of targets. So the word astrophotography means taking space pictures. And these are the types of things that people typically take pictures of when you talk about astrophotography. The moon, of course, the planets, the sun with proper protection on your equipment, comets, which we got some experience with last year. And then deep sky is probably the most popular for astrophotographers. So if you're getting into astrophotography, that's kind of your goal, your eventual goal is to be able to do deep sky objects, galaxies, nebula, things like that. Things that you can't see clearly, or you can't see very much detail with the unaided eye, or with just the eyepiece in your telescope. So astrophotography, like regular photography or normal everyday walking around taking pictures with your phone, is very similar in that you have to take considerations of what you're taking a picture of in terms of size and brightness. And if you're just walking around taking pictures of stuff, normal everyday life, that's probably going to be on the order of larger objects and pretty bright. So this area. And our phones and our consumer cameras are very good at taking pictures in these areas of subject size and subject brightness. I have some comparisons on here for size. The Milky Way is, by comparison, much larger visibly than the planets are. So the Milky Way would take up the entire sky, and planets would just be basically a little speck. And same with brightness, the sun is the brightest thing most of us know, but a distant galaxy is probably imperceptible. There are different levels of complexity for astrophotography. You can start out very basically. You can basically just start out with a camera. You don't need a telescope or anything like that. This is the camera that I have. This is the Sony a6000. I'm going to mention DSLR several times in this presentation, but I'm just basically just referring to a camera that you can exchange the lens on. So this is the kit lens that came with it. It's a 210 millimeter telephoto lens. Very basic, but it's a good lens, has stabilization, and that's something you can start with to sort of learn the basics of astrophotography. If you have a telescope, you don't need a super fancy telescope to do basic stuff. You can get a very beginner telescope, and they have these clamps that you can use to attach your smartphone to the telescope eyepiece, and you can take pictures of things like the moon and planets and things, and I'll go over that a little bit. If you get a little bit more advanced, you can take your camera and attach it directly to your telescope. This is my setup here. I have a 6-inch Celestron Cassegrain telescope, and that's my A6000 just attached to the back with a very basic adapter setup. So most of the stuff that I'm going to show towards the end is going to be with this setup. And then, of course, you can go even more advanced. You can get a bigger telescope, and they have actually special astrophotography cameras that are actively cooled, and they're designed specifically to attach to the telescope and take very long exposure pictures of very faint objects. So starting out with the first thing I mentioned was the moon. The moon is pretty easy to photograph through a telescope, but it actually can be difficult without some sort of a zoom lens capability. So if you've ever tried to take a picture of the moon with just your phone, usually turns out to be just a speck. This picture here on the left was something I took with my Sony camera with the 210 millimeter telephoto lens. It's you can see detail on the moon, but not a whole lot. It's pretty small. That's as much detail as you can get, and that's about as big as the picture is. If you use the smartphone adapter on an eyepiece, you can get much more detailed. You can see there's craters and things on here. And then this is with my my telescope setup with the camera attached to the telescope. I was able to capture this picture and this picture. The moon is, depending on what phase it's in, you can get different things. Like in this crescent phase, if you do a long enough exposure, you can actually bring out some of the dark side of the moon, which is very cool. But that's difficult to do because the bright part is so bright in comparison. For the planets, you can see them through a basic telescope with your smartphone and take some pictures. Here's some pictures of Jupiter and Saturn. You can actually see Jupiter's moons here, but it's very difficult to get those and the planet itself in the same shot because they're so different in brightness. Here's a shorter exposure picture of Jupiter with a smartphone through a telescope. So you can actually see a little bit of banding in there, but you can't see the moons. These are some pictures that I've taken with my telescope and camera. This is done with some post-processing. Typically, when you're doing planets, you can take video, so you get a whole bunch of pictures, and then do some processing on that to find the best frames. When you're looking at a planet through a telescope, you'll notice there's a little bit of fuzziness to it, and that's because of the Earth's atmosphere kind of interfering with what you're seeing. If you run video and take a whole bunch of frames, and then have software analyze all those frames and pick out the most clear frames, you can actually use those to produce your picture, and you get much clearer pictures. So on Mars, you can actually see light and darker features on the surface. You can see the polar ice cap. On Jupiter, you can see bands. You can see the red spot there. And with Saturn, you can very clearly see the distinction between the rings, the planet, and even some of the banding on the planet. The sun is very interesting to look at if there are sunspots. And of course, I have to give the warning here, don't look at the sun. And especially don't point your telescope at a sun unless you have a special solar filter attached. So all of these pictures here are with very specialized equipment. This is just a basic telescope and a solar filter, specially made solar filter. You can see the sphere of the sun. You can see some sunspots in there. This is a picture I took with my telescope with the Sony camera attached and a sun filter. You can now start seeing more detail in the sunspots there. And then if you have a dedicated solar telescope, which has filtering in it to look at a very narrow band of light, you can actually see some details of the surface and as well as some of the prominences around the edge. Comets, I wasn't really sure what to say. It's complicated. Because they vary so much. When you're looking at a comet naked eye, typically it's a big event like we had last year with NEOWISE. This was a picture I took in the morning just straight with my camera, no telescope or anything. And then this is a picture of a comet that I took several years ago through the telescope, much, much dimmer, much farther away. And that was with a long exposure. That was really bringing in a lot of light. So huge difference between these two shots. This is a picture that my friend took with his iPhone with no telescope or anything of NEOWISE last year. So it really depends on what's going on with the comet, how bright it is, how far it is away, as to whether you actually be able to get a picture of it or not. And then of course you get deep sky. This is the really exciting part of astrophotography. So with a modest telescope, you can see, if you look through the eyepiece, you can see a lot of deep sky objects, notably things like the Orion Nebula, the Pleiades, or the core of Andromeda even. When you're photographing these, because they're so dim, you need to be able to do longer exposures. You need to let the camera stare at it for a lot longer. So you need a camera that's capable of that, and most DSLRs can do that. Usually up to 30 seconds is built into the functionality of the camera. An Astro camera, of course, that's what it's made for. And some smartphones can even do longer exposures. So like that picture I showed of the comet, that was, I think that was an iPhone 12 with the 30-second exposure. So now that smartphones are starting to get that capability, you can actually do it with those as well. In order to do a long exposure, you need to be able to track the object. And so you really want to have a motorized telescope mount, equatorial, as was mentioned in the previous presentation. And that's because if you use an Alt-Az, and there are Alt-Az telescope mounts that track motorized, however, because the way they rotate, the picture will rotate within the view, and so you get a rotational streak if you try to do long exposure with an Alt-Az telescope. So equatorial is the way to go for astrophotography. It is possible to do it without a motorized telescope, but I don't recommend it. And considering the technology we have now, it's probably not worth your time. And then, of course, you've got to have clear, dark skies in any case for doing deep sky. You can get by with city lights, light pollution if you've got the right filtering, but that's kind of out of the scope of the presentation right now. So here's some example pictures from different setups. This is a picture of the Orion Nebula through a basic telescope with a smartphone, just held up to the eyepiece. Same here with the core of Andromeda Galaxy. So it's definitely possible to pick up some things with a smartphone and a basic telescope. Here's a shot that I did just with my Sony camera and the telephoto lens of the Orion Nebula, piggybacked on the telescope, so it was tracking. So I forget what the exposure time is, probably something like 30 seconds or a minute of exposure time. If it wasn't tracking, all of these stars would be streaked. I could have done a shorter exposure with a higher gain, but it'd be much more of a grainy picture. And then over on the right is a picture of the same thing through the telescope, tracked. And I think this was about 10 minutes of exposure time with some post-processing. And on the farther end of the spectrum, this is a picture that I stole from our friend Blake, who's got much better equipment and experience than I have. And you can see all the cool pictures and products that they've got over on estesandschmidt.com. But this is the Orion Nebula, same thing that was shown in these pictures here, just to show the range of what you can do with different types of equipment. This is of course on the high end, and the Horsehead Nebula here is also part of Orion, and that's like that's my goal. I want to get a picture of that one day, and I haven't gotten it. So real quick, I'm going to go over some of my favorite photos that I've taken. So here's the Andromeda Galaxy through the telescope. I think these are mostly on the order of about 10 minutes of exposure time with some post-processing. Here's the Eagle Nebula with the famous pillars of creation in the middle, the Whirlpool Galaxy. Got a nice picture of Mars here I did earlier, just a few months ago, when we were closer to opposition. And then, of course, just recently we had the Saturn and Jupiter conjunction. That's a shot through my telescope. Here's one that I was really excited about, and I didn't know that I'd gotten it until I got home and compared it to a star chart. But this is actually Pluto. So I got that for the first time late last year. Here's some interesting passes from the ISS. This one, I think, Bruce, is the one I did with you. That's the ISS passing in front of the sun, and the ISS passing in front of the moon. These were taken a video mode on my camera, 60 frames per second, and I took all the frames and combined them into one shot. Here's a picture from the last lunar eclipse taken up. I think I took this at Griffith up on the lawn when we had a star party. And I like this picture because not only does it look cool with the moon red, but you can actually see stars. Normally you can't see the full moon and stars in the same shot. I think that's really cool. And then also by chance, there was a meteor impact on the moon during this eclipse. I just happened to catch it in one of my frames. You can see that little dot there flashing in and out. That was actually something hitting the moon during the eclipse. Here's a couple of shots from the solar eclipse in 2017 through my telescope. And then our own LightSail 2 spacecraft traveling amongst the stars took this video through my telescope from Malibu on a nice dark clear night. And that's all I've got. You can follow me on Instagram for pictures, because most of the stuff that I've shown here are on there. And I've also got lots of rocket launch videos on my YouTube channel.
Thank you, Justin. Those were amazing and beautiful. We're running a little behind time, so I'm not going to, in fact, a lot behind time, so I'm not going to take a picture right now. I'm going to turn you over to Gio Smosa, who, by the way, has been answering questions already online. And after the session, I'll dig into and we'll try to get some written answers to your questions. Gio is a longtime Planetary Society volunteer, a crucial part of the organization coordinating outreach in Southern California, but he's also a telescope operator at Mount Wilson, president emeritus of the Los Angeles Astronomical Society, telescope demonstrator at Griffith Observatory. the great guy to tell us how to share the night sky with the world. Gio, take it.
Oh my God, that's such a great introduction. Thank you, Bruce. Happy to be here. Happy Valentine's, everybody. I'm going to talk a little bit about sharing the night sky. And actually, I'm not seeing my slide move forward, but let me try that again. There we go. Okay, so, sharing astronomy in the night sky with others, and I'll go as quickly as I can because I know we're behind time, but I wanted to start with a quote from one of our founders, Carl Sagan. We are made of star stuff. So if we want to share astronomy and share the night sky, we basically have to share ourselves, share our knowledge. And so the cool thing is I'm very honored and happy to work for and represent many organizations, but I think where I make one of the biggest impacts is here at the Planetary Society, where I've been outreach coordinator since 2010. And we have a team of about 200 volunteers. And the great thing is we do have some scientists among those volunteers, but the majority of our volunteers are just everyday folks, mothers, fathers, brothers, and sisters that just love to share their passion and their love for science and astronomy. And so when they become volunteers, they always ask me, do I need to own a telescope? I don't know how to work one. I don't know how to run one. And it's okay. You don't need to. I think we just want you to go out there and share what you can. Majority of the time when we're doing outreach, we go into individual classrooms and talk to kids and get them excited about science and, bring some pretty pictures and hand out stickers and magazines, and kids love that. A lot of times our schools are so happy to have us there that rather than just giving us one classroom, they'll turn over the whole school to us. And so we've done this huge presentations at schools, which is really awesome. We go to colleges and astronomy clubs and pretty much anywhere they allow us to talk. Here we're at Cal State Northridge during their STEM careers night and just talking to people about, trying to convince them to try out a STEM career. We even create programs for our different organizations. These young ladies here are from the YWCA, and they wanted to learn more about women working in engineering. So we put a whole day's worth of planning for them so they can come and talk to some of our female engineers. We work with the Girl Scouts, the Boy Scouts, Rotary clubs. It doesn't matter. If you let us talk, we will talk. You can tell I'm pretty good about talking. I think where we make the most impact, though, is when we actually go to support our local schools. So 2019, we visited 79 different schools to do outreach for their science night or astronomy night. And that's where we just show up and talk to people and share our passion and, of course, hand out material, but even have some fun activities that they can share and get excited about. So going to the schools is really important, and that's a good way to share things. And there's Bill Nye bobblehead. Bill Nye can't always be with us, so oftentimes Bill Nye bobblehead has to step in and join the fun. This is the third rendition of Bill Nye bobblehead. Kids love him so much, sometimes they hug him to death and his head pops off. So be gentle if you see him out on the road. So just getting out and talking and sharing science is the cool thing. It's how you can contribute. And one of our favorite activities is we have magazines, old magazines. We've been at this for 41 years now. So we recycle some of our older magazines, which have a lot of pretty pictures, and people look through these magazines and find something cool. We cut it, press it, and now they can wear it and have a memory. And the cool thing about it is it takes about a minute or two to cut and press an image. So we explain what image they chose. So if they chosen a nebula, we can talk about what that nebula is doing and how beautiful it is and how stars are being born with it. So with fun activities, we can actually teach science. Here, we're actually making little bracelet beads that glow in the dark. And so kids get excited about putting their own bracelet beads together. And oh my God, this was fun. We actually helped NASA in their campaign to have the kids draw what an exoplanet would look like. And so we just hand them a bunch of crayons and paper and say, here you go, tell us what an exoplanet looks like. And the amazing thing is we were able to scan these images and upload them. And now they're flying in outer space on the TESS spacecraft. That's the telescope that's out there searching for exoplanets. So that's how we engage the kids, because now, since their artwork is in that spacecraft, they're following that mission and get excited. And that's what the Planetary Society is good at. We're always trying to promote missions and get people excited. So with our current spacecraft that's about to land on Mars, 10.9 million names went out there, all of our Planetary Society members. And I figure I might as well put my Instagram name there. So if aliens ever capture that rover, they'll at least be able to look me up. So that's the fun thing, guys. We just need to get out there. And the tough thing is most people are afraid of what to say. You know, I'm not a scientist. How can I prepare? And the Planetary Society does a really good job of being able to provide you with the right tools. Whether it's Bruce Betts, our own Bruce Betts here, he actually teaches an astronomy course. And so you can actually take his course. You know, it's really fun. Unless you pay to college, you're not going to get the degree, but who cares? You get the knowledge. That's what really matters. We put out a magazine 4 times a year. Our blogs on our website, oh my God, they're amazing. Neil deGrasse Tyson was just recently asked, how do you stay so up to date on all the space missions? And his reply was, I follow Emily Lakdawala on her blog because Emily's so up to date on everything. Bill Nye is always putting all these fun videos out there. And our planetary radio, guys, you gotta find that radio. It's a weekly show, and you can get it from our website. You can get it from wherever you get your blogs. Find it. It even plays on some radio stations throughout the country. NASA, it's a good source as well. You can get just like the APOD, Astronomy Picture of the Day. Every day you get a beautiful picture sent to your phone or tablet or your computer, along with some information as to what you're watching. And join an astronomy club. Astronomy clubs are like 20 bucks, 30 bucks a year to join. They're relatively cheap, and you get to learn from people that have been doing this for a long time. So if, you know, getting out there, just talking to people, it's a good way to get started. And yeah, eventually you want to get some equipment. So there's stuff that you can bring, like solar glasses. You know, solar glasses are a big hit whenever we do outreach, and they're cheap. They're like $1 a piece. Although I strongly suggest you get yours now, because we do have an eclipse coming up in 2024. And every time we have an eclipse, these dollar glasses can get bumped up to like 200 bucks on eBay. So buy one now just to have it on hand. Handheld filters. This is the handheld filter that we built. And so kids enjoy looking at the sun safely through these handheld filters. So just right there alone, talking about the science behind the sun and how eclipses work is really good. And many of our volunteers, our outreach team, they don't have telescopes, but they have a phone. They have a tablet. So you can upload some fancy software. Most of them are cheap. And with the software, you could just point out where things are in the night sky. It's really amazing. And a lot of these apps even have features that will show you where exoplanets are located or where a comet might be. So it's really awesome, guys. And as Lucia said, eventually you're gonna wanna get binoculars. And my thing is go cheap. Get a $30, $40 pair of binoculars. Low power so you can see more of the sky. And if they fall and break, who cares? It's only 30 bucks. You know, once you get the hang of using these $30, $40 cheap binoculars, then you can upgrade to the heavier, more expensive ones. Yeah, once you go really heavy on this binoculars, you're gonna have to get a mount because it's gonna be too heavy for your hand. There's Ocean, by the way. She's one of our great volunteers. Hi, Ocean. Yeah, you don't wanna go too crazy. If you go too crazy, things get too complicated. And if you see this guy, do not look through his telescope. Everybody knows stormtroopers are horrible at aiming. So you'll never see anything through that telescope. Now, moving away from Star Wars into Star Trek, Tim Russ, who everybody knows as the actor from TV Voyager, Star Trek Voyager, he volunteers and comes out with his telescope a lot. And he's really cool. Although I do kind of miss not seeing that outfit or his Vulcan ears, his pointy ears. So a lot of times we'll just stand behind him and augment his ears and make him look a little bit more like he's supposed to, right? So yeah, so Tim, it's really cool. He'll show up with his telescopes. He's got big ones, but a lot of times it's the little ones that can see more. So, you know, you don't have to start out with huge, crazy equipment. There's this crazy guy. He's in our panel, right? Yeah, he's got that fancy antenna in the back and he's got that telescope in the front. He can't run both of them. So a lot of times we rely on volunteers to show up and help us run the extra equipment we bring. Aram here, Aram used to just show up and help us run the telescopes, and eventually he got so good at them, he decided to buy his own. And that's what happens. There's Matt. Hey, Matt. Matt not only brings his, but brings one that the Planetary Society owns. And so, yes, we just need you to get out there. Liam, hey, Liam. Liam is amazing, inventor of ISS Above and now helping us track light sail. Yeah, so we just need to get out there, guys. We want to see you out there. Oh, David. David's really great. David takes a lot of astro images for us. So a lot of times you go to our website and see a picture of the moon or sun. I've usually stolen it from David. I'll give him credit at the bottom, but he's okay with me stealing his images. He's really cool. So yeah, and our volunteers often bring reading material so that if we don't have the answer for something, we can look it up. But the good thing is with a lot of us present at these events, oftentimes one of us may know the answer as to what's going on and what's out there. So I'm going to leave you finally with this. Telescopes are awesome. Telescopes are great. But more important than that, we need you. We need your star guts. We need you to come out here and help us change the world. So with that, guys, I turn it back to the panel. Thank you so much. I hope you do get out there. Once pandemic is over, I hope you do get out there and help us make a difference. Thank you.
Thank you, Gio, and thank you to the panel. I apologize to everyone that we've run over, and so won't be taking more questions. We will take a look at those online, and remember to download the resource guide, and you can go find a link up to more information. Thank you all, and have a great day at Planet Fest.
Thank you so much to our speakers for sharing their expertise with us today. During your short break, please stop into our exhibitor section. We have some tremendous supporters who help make Planet Fest possible. Click on exhibitors on the far left in Whova to see their profiles. And coming up next is a unique opportunity to learn more from some more folks whose passion for space has fueled some really creative endeavors. Please click on agenda to the far left and choose a session title to get connected. Thank you so much.